to this computer. Amazing. I am now recording, so anything that you say on this call will be recorded forever, and then it will be on YouTube. So maybe we'll go viral. I feel like I made that joke last week too. So to kick it off, Group 7, how would you like to present today? Group 7 has already presented. Okay, awesome. So Group 8 doesn't exist. Group 9, so I believe Group 9 sent me a video. So I will put that up on my screen and we will watch the video, and then we can ask Group 9 questions after the video has completed. Okay, so before we kick off the video, does anyone have any questions, comments, or concerns? Okay, can you confirm that you can see the video? It should be Scrapey. Can someone on the call confirm that you see Scrapey on the screen? Okay, we have one no. All right, great. Well, that's why we ask. Let's try again. How about now?
Yes, we can see Scrapey.
Amazing. Okay, cool. Now we can get started. Great. Okay, so without further ado, Group 9 will be presenting Scrapey. And obviously, stop me if you cannot hear it.
Hi guys, my name is Sandro. Today, my partner Yao-Ting and I will talk about the Scrapey package as our topic of the presentation. So let's get started. The Scrapey package is an open source and collaborative framework for extracting the data from websites and processing it, then save it. Something important in the Scrapey package is called spiders, which are the classes that define how a certain site or different sites will be scripted, including how to perform the crawl and how to extract structured data from their pages. So you might be wondering, after we've learned beautiful soup from our lectures, why do we want to spend more time on the scripting package? Well, so first it's a complete package, whereas the beautiful soup is just a parser. And since it's a complete package, it takes more time to learn all those functionalities, whereas the beautiful soup is relatively easy to understand and then can get smaller tasks done in no time. But if you have any tasks that involve a lot of URLs or you require multiprocessing, the Scrapey package is definitely the choice you want to go. Last but not least, the Scrapey package, you can have more customization if you're using the Scrapey package, because there are something called item pipelines that allow you to write functions in your spider that can process your data, such as validating data, removing data, and saving data. So I believe for any data analytical tasks that involve scraping data from websites, the Scrapey package is a very good choice. A real-world use case would be since the flight tickets price change on a basis of like every day or every week, you can write a program and use the Scrapey package to script the prices from multiple websites, and then make your program run like every day or every week, so that you can get the best deal. And then this picture is a demonstration of the Scrapey architecture. There's a lot of information there. The way I interpret this whole thing is to think of you as the user to be the boss, and then you have a project assigned to this group called Scrapey. So the engine here is acting like a a coordinator. So first, the spiders talks to the engine, say, hey, this is the website that the user want to script data from, and then here is an URL that I can provide you. So the engine hands over the URL to the scheduler so that the scheduler can, put the URL in the line. And then after that request is processed by the scheduler, it gets sent back to the engine. Then the engine can send that request through the middleware to the downloader. And then once a page finishes downloading from the internet, the response gets sent back to the engine from the downloader. And then the engine can, send the response from the downloader to the spiders, again through a middleware. So now the spiders basically do like two tasks for processing the data. One thing is to extract all the script items and then send it back to the engine so that the engine can have the items to the item pipelines for further tasks such as cleaning the data, validating data, or saving the data. Also, since on a page there are a lot of follow links that can be further routed. So those URLs are sent back to the engine as more requests, and then the engine can send those requests to the scheduler again, so that the scheduler can reschedule every URL, and then the whole cycle starts over and over again until all the data is scripted. So my partner Yating will take over, and then we have an example of how to use the scripting package.
Thank you, Sandro. Hello, everyone. I am Yati Yuan. I will show you a simple example in the following presentation. This example uses script to crawl the text, author, and tag in the following website. This is the website we want to script. So in the first step, we need to install the script. We can use the import scripted code to install it in the Jupyter Notebook. Then we need to create our spider. As Sandro mentioned before, spider is really important in the scripted process. But before we create the spider, I want to introduce you first how to create the item pipeline, because we need to assign the item pipeline into the spider. So it's better to create it first. The item pipeline is the place where we can process the item with scripts. You can drop items, you can save items to database, or extract items into structured data. There are some components in the item pipeline. The most important one is process item. This function is coded for every item pipeline component. It can either return a dictionary with data, return an item object, return a deferred, or raise drop item exceptions. There is the close spider function. This function is coded when the spider is closed. Open spider function. This function is coded when the spider is opened. So we have our item pipeline here. There are so many functions of the item pipeline. You can write items to JSON file, as we did here. Also, you can write items to CSV file, write items to MongoDB. In the following pipeline, we can see the pipeline first is create a single file. Is the called results JSON line file. JSON lines essentially consist of several lines where each individual line is a JSON format. So when the spider opens, it will create a file. And then the pipeline will process the items. It will store each items in one line as the JSON format, and then store all of the line into the file, the court results JSON live file. And when the spider close, the close spider function is called, and the file will close. Okay, now we have our item pipeline, so we can create the spider now. The first step to create a spider is to take the spider class provided by Scrippy and make a subclass out of it. We call the subclass the court spiders. The subclass has methods to how to follow URLs and how to extract data, but we need to give some information to it. First, we give the spider the name, court, and then we give the spider the URLs to start from. Also, we can set up our spider configurations using custom settings. The custom setting is a dictionary of settings. In our example, we have 4 settings here. It sets the logging level to warnings. Otherwise, the notebook is overloaded with debug message about the retrieved data. Also set the item pipeline. We sign the item pipeline we already create and sign to the item pipeline. And then is the feed format. The feed format is the serialization format to be used for the feed. In our example, the format is JSON. And then is the feed URL. Is the URL of the expert feed. After that, we need to create a parse function. The parse function is a default callback used by Scrippy to process downloaded response. So in this class, the parse function is after step 6 and before step 7, because parse function is parse the response. So when we get the response in the spider, the parse function will parse the response and then return the items. This is what the response looks like in our examples. Since we want to generate tags author and tag in each code, so in the parse function, we access to each code and then generate tags author tags, save it into a dictionary. So this is what the spider looks like at the end. We have our subclass, the start URLs, we have the custom settings, and also we have the parse function. After we create the spider, we can process the spider. In the Jupyter Notebook, you can use the crawl process to process the spider. After we process the spider, we will have our file, JSON live file. So we can use the pandas to transfer the JSON file to a data frame. So this is what the data frame we want at the end. We have each code in each row, and also we have 3 columns, author, tag, and the text. And this is the reference we use in our presentation. Thank you so much.
Okay. Thank you, Group 9. Very, very informative presentation about Scrapy. I definitely think that you have a good grasp on how the tool works. Are there any questions from the class to Group 9 regarding? Yeah, go ahead.
Professor, I'm Yati. I have a question about our topic, because after Fangzhou and me discuss of that problem, we still can get the correct answer. Could you go back to the video and go back to the code?
I can try. One moment.
Sorry about that.
No, that's okay.
Could you go to the custom setting?
Forward and backward from here.
I think is after the class. Yes, here. I have a question about it because this is the original code in the examples. The feed format is JSON and feed URL is called result.json. But based on the item pipeline, I think the feed format is JSON lines and feed URL is called result.jl. And also I run the code, I changed the code and run it. It still works, but I don't know which one is correct. So I still put the original code in the presentation, but I just don't understand why it used JSON, not the JSON lines.
Got it. Okay. I think, generally speaking, I think you've got the point across, and there is a difference. Is the question to Feng Zhao or is the question to me? I'm not quite sure I understand.
The question is, in this example, in the original code, the feed format, can you see
Yes.
that is JSON? But based on the item pipeline, because in the item pipeline, it exports the JSON lines file.
Okay. Got it.
Yeah, I think it's before it.
Oh, it was before it?
Yeah, and before it. And before it. Yeah, here.
Okay. So I see. So, okay. So your output is to a .jl file.
Yeah.
Okay. So I'm sorry. I'm not quite sure. I still understand your question. Your question is why in the configuration do you configure JSON, but in your class you configured the JL as your output?
Yeah, because in the item pipeline, I think it exports the JL file, but in the Spider, the item, but in the Spider, the custom setting, the feed URL is .json, not .jl.
Okay.
Yeah.
So, okay. So with that in mind, what would have happened if you had changed the configuration to
The result is the
feed
same.
format?
If I change
the
the feed format, yeah, the result is the same, but I don't know why the original code used JSON, not JSON lines.
I do not know either. Without digging into this more, I don't think I have a good answer for you. But ultimately, the difference between JSON and JSON lines is negligible, right? I mean, it's the same file. It's just the formatting is different.
Oh.
Right? JSON lines is just an
Yeah.
entire JSON packet.
Yeah.
Without any line breaks or indents.
Oh. So it's almost
Correct.
the same thing.
Exactly. So the interoperability between JSON and JSON lines is probably the same as saying, like, let me think of an example. I don't know that I probably can't think of an example, but it's just a matter of formatting. Like, you can probably read and write JSON interoperably between JSON and JSON lines formats. It's probably Python may be able to actually handle this without you even noticing.
Thank you. Thank you so much.
Sure. Yeah. Are there any questions from other students about Scrapy and the use case that Feng Zhao and Yating have presented here? If you don't feel comfortable speaking, feel free to type it into the box as well. I'll also remind you all that for your final project, you will need to use at least one advanced presentation topic. So this is a great way to source data from the internet if you wanted to do web scraping as one of your data sources. So something to keep in mind there. Okay. All right. Group 10, are you ready to present?
Yes.
Okay.
So
And I'm sorry, who's speaking right now?
I'm Wei, and my teammate is Shanshan.
Yeah.
Okay, perfect.
We're going to do a live presentation for about 10
Okay.
to 15 minutes.
That's great. So in Zoom, you have the ability to share your screen. Let me know if you're able to do that.
Can you see, or can you all see the screen here?
We can.
Okay, now I'm going to start our presentation. Our presentation topic is SQL alchemy. I'm Wei, and my teammate is Shanshan. Now she's going to talk about the introduction part.
Hi, for SQL Alchemy. SQL Alchemy is a Python SQL toolkit and object relational mapper that gives application developers the full power and flexibility of SQL. And in other words, SQL Alchemy provides a nice Pythonic way of interacting with databases. So rather than dealing with the difference between specific dialects of traditional SQL like MySQL or SQL Server, you can leverage the Pythonic framework of SQL Alchemy to streamline your workflow and more efficiently query your data. And then I'll explain a graph. It shows a brief overview of how SQL Alchemy works. And yeah, and the progress is from the bottom part to upper. The bottom part is DB API. We know for different database servers, they provide different database APIs, and the engine of core takes care of the details, such as the connection pooling and dialects, so that a programmer does not need to worry a lot about how to access the database. The SQL Alchemy pool also provides SQL expression language and an interface to manipulate the schema or data types in the tables directly. And SQL Alchemy ORM is built upon the core. It's optional, but when people use SQL Alchemy, they deal with the domain problem rather than focus on specific tables. So that made the main difference between SQL Alchemy and SQLite. And I remember another group has introduced SQLite, but SQLite is more used to store and retrieve structured data from file. But ORM maps your database to Python objects, and it provides a set of tools that let you interact with your database models consistently across database engine. And next, there are some example codes about the core and ORM. And so the first one is ORM. We can see it works in a more abstract level. After these lines of code are executed, we will get two tables in the database and with the given one-to-many relationship. For example, from the picture, the relationship is one department has multiple employees and one employee belongs to exactly one department. So it deals with domain problem. But for core, next, it's more specific to deal with things inside the database. Here we created two tables in the database. One is users and one is addresses. So next, my partner Wei will show you about a project that uses this package and show how SQL Alchemy can play a role in specific problems.
Hi everyone, I'm going to present our project. Basically, I'm going to, this is a web application which utilizes multiple frameworks, and it consists of about 1,000 lines. Because our presentation time is limited, we're going to only present how the SQL Alchemy works in a real life program like this. So our code is published on the GitHub, so everyone who is interested may have a look on the internet. And this is the basic schema of the project. Our project is called Virtual Stock Exchange. It basically uses the closing price from Yahoo Finance, and it allows users to simulate a bunch of orders such as buy and sell, and see how the return and things like that. Because it's a web application like this, it's a web application. So basically, when user clicks anything in the browser, it fires a request to the web server, which is running on Flask. And the Dash framework takes care of the responses, the requests, and uses the SQL Alchemy to manipulate the SQL Server backend, which is running on my local computer. And the SQL Alchemy, ORM uses the results from the SQL Server to present the result through the Dash framework to the browser. To repeat, there are three main frameworks in our project. One is called SQL Alchemy, which basically takes care of the database part, and one is called Dash. Dash actually Flask. Dash basically contains multiple components, such as Flask as the web server backend, and also it uses React. It uses React to present in the web browser, and also it contains Plotly, which allows visualization part. And this is the schema of our database. Let us have a look at what our project looks like. So this is the virtual stock exchange. It contains two parts. Well, one part is called an administration part, which allows user management and financial data, which can pull in the closing prices from the Yahoo Finance. And this one is the database management, which shows the data in the database. And it also contains a student page, which basically allows people to simulate buy and sell orders, so that we can see the overall gain and visualize the results here. So today, because our topic today is SQL Alchemy, I'm only going to present one function, which basically shows how SQL Alchemy works in a web application like this. For example, there are five users in the system. And now I'm going to add one user called 5As, 1, 2, 3, 4, 5, 6, admin, my name. And when I click add, it does the following thing. The JavaScript running in the web browser sends a request to the web server. Because Flask is a component of Dash, when a Dash got the request from the browser, it processed the request and then uses the SQL Alchemy to manipulate the SQL Server backend, and then fetches the result and present it back to the browser. So we can see that after I click in add, there is one more user in the system, and the user is showing here. And now I'm going to presents the transaction in the SQL Alchemy. There's another concept called unit of work, which is basically speaks of the same thing. It means that, for example, when I click add user, there are multiple operations must be done atomically, so that even if there are multiple users using that web application, all the operations are done in one time and atomically, so that there won't be inconsistent result between users. And this is the function related to the add button here. When I click add user, it does the following thing. First, it creates a user's object using the parameters from the web browser. It pushes the object to the session, and then it has another object called portfolio with a $1 million cash. And then it has the portfolio object to the session. Finally, it commits everything to the database. So basically, this is a transaction. This is in this transaction, when everything is finished successfully, it will be committed to the database for one time, which means atomically. And this is what is happening in a transaction. By default, the SQL Alchemy sessions are works like this. They work in a transaction way, and when the final line which is fired, everything is pushed to the database for each session. Now I'm going to present the database relevant code in our project. This file shows how SQL Alchemy and how database work, how SQL Alchemy connects to the database and manipulates everything. So first of all, I provide the connection string here, and then I do the following things. One more thing. In this file, I'm using a dialect of SQL Alchemy called Flask SQL Alchemy. Because this is a web application running in Flask, the Flask SQL Alchemy library provides some shortcuts for the common objects, such as metadata, such as engine, and also it takes care of the session scoping problem. Which means that in a web application, there are multiple users. Results should be consistent within each session. And the Flask SQL Alchemy takes care of it, so I don't have to write a lot of other codes, redundant codes. So when the connection string is provided to the engine, it takes care of the details. And then I do the following. I use an extension called AutoMap extension. This extension is a extension of SQL Alchemy, which reflects the existing schema from the SQL Server into the metadata, here in base. And then I extract the metadata from the base object to these objects, which is users, portfolios, and things, historical price, and things like that. And these objects are later used in our programs, such as, for example, just the add user example. The users objects here and the portfolio objects here are imported from this file, so that when I'm writing the program logic, I don't have to know about how I should connect to the database. For example, if this kind of web application is developed by multiple programmers, then if I'm one of the programmers, I don't have to know I can connect to the database. What is the connection password? I don't know that. Don't need to know that. I just need to use the ORM. And the ORM is basically the most important feature of the SQL Alchemy. And that is all for today's presentation. This is our reference. Are there any questions?
No, thank you both. I think this was really, really in depth, and I definitely think that you did a proper job demonstrating SQL Alchemy. Any questions for the group? Any questions about SQL Alchemy or really their web app? Wei, how long did it take you to stand up the web app end to end?
Basically, I wrote it a long time ago for about 1 week because because there are many details that I have to take care of.
Got it. Okay. Any questions for the group before we move on? Again, feel free to type them in the group chat. Okay, we have a question from Gier. When you run the app, do the codes run automatically?
Yes, I'm going to actually. Contrary to the previous groups which runs the codes in the Jupyter notebook, we know that in a Jupyter notebook everything is a script, so that when you press Control Enter, it runs that line interactively. But actually, our code here is in Python files. And the entry point is the index.py files. And our code is in the GitHub so that you can inspect the details there. And basically it does the following thing. When the entry point is, when I run this program from here, the server is running in the background. The Flask server is running in the background so that I can do anything I want here in a web browser. So in a real production environment, it means that by executing the Python index.py, then the server is up and running, so that the users can use them in an online environment. This is how our programs runs. Yeah.
Okay, thank you for your question, GR. Any other questions about their advanced topic here? Okay, all right, thank you very much. With that being said, I will share my screen and we can jump into the lecture. Just as a reminder, next week, groups 11 and groups 12. Is that right? Does that make sense? I feel like that makes sense. That was just group 10, so 11 and 12. Confirm in the chat if you are 11 and 12, confirming that you'll be going next week. This would be, let's see, groups 11 and 12. We have Justin and Zemo in group 11. Okay. And group 12, we have Trisha and Tanushri. So you're both set to go next week as well. Okay. And again, you may record ahead of time or like Wei present in real time. Okay, and I'm sorry, that was Wei and Shen Shen. So today we're going to be covering a little bit about APIs using Python. So specifically, we're going to be exploring Twitter's API, and the TweetPy Python package for fetching data from Twitter. So first things first, in order for all of this to work, I had to create a Twitter account. I did this last year when I taught this class for the first time. So I created a Twitter account called Ben the Professor. You can see I have no tweets and I'm not following anyone. So this Twitter account is it's only for the purposes of leveraging their APIs. So there is going to be a series of instructions that you can follow optionally. There's nothing that requires you to actually install this on your machine, but we're going to walk through exactly how you can access Twitter's API using Python, but it does require you ultimately to have a Twitter account. So that is why I've created one here. And again, it's Ben the Professor. You can follow me. I won't follow you back. Additionally, in case you don't know, Twitter is a social media platform for sending short messages, mostly just to everyone on Earth. I guess you can also send specific messages to specific people, but that's not really its main process. It's more yelling with a microphone on social media is how I understand Twitter to work. I don't have a regular Twitter account. This is my only interaction with Twitter. But it is a great source of information about trends, news, etc. So with that in mind, we're going to need a Twitter account. We're going to need to authorize that Twitter account using something called open authentication, or OAuth, and we'll walk through exactly what that means. But at the end of the day, what we're actually going to be doing is asking Twitter via API, which is again it's the application. I can never remember what API stands for, but it's a
interface
format for application protocol implementation or something. Application programming interface. There we go. It's a way for one tool to ask another website or another service for information or for a response. It's a communication. So we're going to be leveraging the Twitter API to actually ask Twitter for data. The data can either be about a specific user. The data can be about trends based on a locality, so maybe the United States or New York State. We're going to be asking specifically about a user and their current configurations, or a user and their timeline, which is sort of a representation of tweets over time. And in case you didn't know this, a tweet represents a message sent on Twitter. All right. So before we get started, I have already done this, but if you're interested, you may. And again, this is optional. The homework does not require you to have TweetPy installed, mostly because it could be a little tricky to install here and there. But what you'll need is conda install c conda forge TweetPy. So that's just asking for the TweetPy package from conda, and conda is specifically using conda forge, which is like their open source library package installation guide. TweetPy is a open source software solution. There's also a native Twitter API, but I personally believe that TweetPy is a better package than Twitter's API or Twitter's specific Python solution. So we're going to use TweetPy. Oh, apologies. Additionally, these Python packages don't appear to install directly from Anaconda. So that's why we have to do this conda forge thing. If you just do conda install TweetPy, you may run into difficulty. So overview of Twitter and the Twitter API. One way to describe Twitter is a microblogging service that allows people to communicate with short 114 character messages that roughly span to thoughts or ideas. That's sort of the idea behind Twitter. Since that original tweet, they have increased it to 280 characters. You can also post pictures, videos, etc. But more than anything, it's a great way for individuals to communicate ideas and thoughts. Our president uses it quite frequently. The Twitter homepage, you can sign up for an account, and you'll actually need to do that if you want to follow along in this lecture. Once you've signed up for Twitter, you can then have access to all of the Twitter API and the authentication keys that you'll need to actually access Twitter. The view from the Twitter page can show you trends, the tweets of users that you're following, and tweets addressed to you, and allow you to compose a tweet. So you can actually use TweetPy to automate tweets as well. So let's say you had some sort of web app, like what Wei was showing earlier, you could actually have it send out tweets on your behalf based on this package. Additionally, other companies have written other clients that you can see here. Nothing is stopping you from investigating these, but again, we're sticking with TweetPie. And here's just some overall information about Twitter and why we're using it. So this data is 2 years old now, but at the time there were 326 million daily active users, 500 million tweets sent per day, 80% of tweets were using it on a mobile device, and the number of Twitter daily active users is 100 million. So monthly active users versus daily active users. So what are users, right? And it's important that when you're pulling data from websites, you have a good understanding of entities. So what is a tweet? What is a user? What is a profile? What is a friend? These are entities and relationships, and it's really important for you to understand how they operate, especially when we get to the API layer. Again, I also want to reiterate, if you have questions, feel free to interrupt me or post it in the Zoom chat. I have that available on my screen. You just can't see it. Okay? So what is a user? A user is simply a representation of a person, a company, or an entity. That person or company can be real or imaginary. For those of you that are fans of The Simpsons, the television cartoon comic, at Homer J. Simpson is a Twitter handle for Homer, which is the main character of The Simpsons. There are also verified accounts for celebrities and public figures. They are there to exist as an affirmative representation that Twitter, yes, this person is the real Donald Trump, the real Justin Bieber, the real Dwayne The Rock Johnson, for those of you who know those particular people. So now that we have a Twitter account, like I mentioned, this is Ben the Professor. If I wanted to tweet, I could. You may follow me. I will not follow you back. So now that we have a Twitter account, we can now access the Twitter APIs. So the link is in here, but specifically there's documentation about specific API calls that you can make. So here are the specific API calls that you can make. You can search tweets. You can fetch account activity. You can filter real-time tweets, kind of like a net. So you have like a net and certain things go through and you just kind of catch like a snapshot in time of what people are tweeting. You can fetch direct messages. You can fetch you can embed tweets and timelines in a website. So it's a different type of API. And you can also programmatically insert ads into Twitter, also using an API. So this is the different aspects of how you can interact with Twitter programmatically, which is to say that you leverage the APIs to communicate with Twitter, either the application or to render Twitter in your website. So a tweet, here's just what a tweet may look like. Sometimes the strongest PW in the world doesn't help. Humans still the weakest link in the security chain. Again, it's a 280 character snapshot. It doesn't have to correspond with any particular topic, although if it does pertain to a topic, there are special things called hashtags, which allow a user to tag metadata about a tweet. Additionally, you'll see here RT stands for retweet, which means that someone has taken something that someone has tweeted and simply responded with the same information to the people within their network. And a network represents people that follow or people that you are following. That is considered to be your network as a user. Okay? Metadata associated with tweets. A tweet received through the API has metadata, include the user who sent it, whether or not it was retweeted, and in fact, if it was retweeted, how many times was it done so? How many times was it made a favorite? A favorite is another function of Twitter where a user can have a favorite tweet tagged on their specific profile. It can also indicate any entities that were specifically tagged or any places that were tagged from a geolocation standpoint. All right. So with all that in mind, we're going to start with the standard search API. Although the tweet field guide page lists all of the metadata, not all of the metadata is available with tweets collected from the search API listed in the REST API and the Twitter documentation here. So there is some metadata that's listed, but not every single tweet has all of that metadata associated with it. It's based on what the user has tweeted. Or if, let's say, a tweet never gets retweeted, none of that reference data would be metadata would be available. Additionally, here's some other information about Twitter nomenclature. So a timeline, Twitter uses the idea of a timeline to organize tweets into chronology, sorted groups. So let's say you have tweets that were posted in the last 30 days. You'd have tweets based on timestamps sorted by when they were posted from most recent to oldest. A user timeline contains all the tweets that were tweeted by the user all time. And a user's homepage contains the tweets of everyone that they are following and is what they see when you log into Twitter. So the timeline is sort of what's been going on with the people that you're affiliated or the accounts that you're affiliated with in your network. Streams are collections of tweets flowing through Twitter in real time. Obviously, it's not real time. It's sort of near real time because once you've captured some history, even if it's seconds or minutes, it already occurred in the past. So it's not necessarily real time. You can think of this as the public fire hose of all the tweets. And at specific times, it can be very high volume. So if you actually want all of those tweets, you need a paid account to access the streaming API. Otherwise, you're throttled to about 1% of those tweets that are available. Other notable things about querying Twitter. When we use the search API, it allows us to search for tweets containing particular keywords from the last week, so just the last 7 days. The search API, you can also get all the tweets from a particular timeline. So if you know the user, you can go all the way back in time as far as you want. We're not going to be using the streaming API. This is the fire hose concept. And then lastly, the streaming API does give you real-time access to tweets, but doesn't go very far back in time. All right. In order to leverage Twitter's API, you do have to have something called open authentication ready to go on your machine. This is something that has a sort of a key encryption provided by Twitter that allows you to connect to their service and has some directions here. Open authentication, or OAuth, is a much, much broader topic than we're going to cover in this lecture, but I wanted to introduce it here because it is a requirement for us to access Twitter. You can think of implementations of OAuth as sign in with Google or sign in with Facebook. What that allows you to do is you can actually access applications that have or are a part of third-party networking protocols that leverage sign-in criteria for Twitter. So when we're scripting our API here, Twitter treats your script as a standalone application that's leveraging its sign-in capabilities. The same way that you might use, let's say, Zoom, the video conference software, you actually may be able to log into Zoom using the Facebook network. Zoom allows you to connect directly to Facebook using open authentication by allowing you to sign in with Facebook, confirming that, yes, you are the user, and then you can then thereby use, for instance, Zoom, the application. There are a lot of different ways that different applications use this type of authentication, but the most popular way is through OAuth. A very large company that uses this would be something like Microsoft. What is it called? Oh, why can't I think of it? Microsoft has a version of OAuth. Okta is another very popular one that's used with large enterprise organizations. And if I think of the Microsoft one, I'll circle back on it. So once you've actually, set up your Twitter account, you're actually going to need to go into Twitter Developer Portal, and you're going to create what's called a Twitter app. So like I mentioned, the same way that Zoom would connect to the Facebook network, you're actually going to create a Twitter app. And within that app, you'll be granted access to Twitter API keys and the OAuth API keys. So this will allow you, number one, to access Twitter using your Twitter API information, and it will allow you to securely access the Twitter network using the OAuth information. Why you need two sets of API keys, I can't specifically speak to that. It's more about the way that Twitter has designed its network There are other services that don't require both OAuth and API keys. For instance, if you wanted to use IBM's Watson APIs for data analysis or machine learning, you tend not to use the OAuth. You actually only need to use the API key. Okay, so I believe we're really kind of just ready to get started. So before we jump in, any questions about Twitter, about connecting to Twitter, about Twitter APIs? Otherwise, we can get started into the Pythonic aspects of today's lecture. So I'll pause for questions.
Yes, Professor, I have a question.
Okay, go for it.
So how long can we retrieve a tweet? Like, what kind of a period can we retrieve it?
Good question. It depends on how you want to access the tweet. So first of all, there is no way to access a unique tweet. You can either access all tweets filtered by some criteria, by like hashtag, keyword, or geography, or you can access a specific person that has tweeted. If you access a specific person, you can get all of the tweets they've ever tweeted. If you access a specific, let's say, tweet criteria like keyword or a specific topic, then you can get all of the tweets from the last 30 days.
Okay, got you. So the reason,
alternatively,
the most reason will always be included.
Yeah, go ahead. Sorry. You can go ahead and ask your question. I think there may be.
Oh, sorry. There's a time lag. So my question was, my question was that the most recent tweet will always be extracted. Is that right?
That's correct. That's correct.
Got you. Thanks.
No problem. Any other questions? Yes. So there's a question in the chat. So Gier asks, you may need a developer account to create the application. That is correct. You do need a developer account, but before you can create a developer account, you need to create a regular Twitter handle or Twitter account. Creating both accounts is actually fairly straightforward and is documented in this notebook. If anyone needs help creating the account, feel free to stick around after the lecture and we can work through that. And actually, most websites that offer an API querying tool like Twitter, you actually will need to create an account, because the way that it works is that you'll be granted some sort of API key. The API key allows the system to know who is asking, who is requesting this data. It also allows things like paid services. So maybe you can get a free account and allows for 1,000 API calls per week. But if you exceed that, you need a paid version of your API. So keys allow for some level of accountability between user and application. Any other questions about anything so far? Okay. All right. So getting started with TweetPy. So import TweetPy, import JSON, and import prettyprint. That's how we're going to start off the lecture from a Python point of view. Let me make sure that we're actually typing. Okay. I'll remind you that if you want TweetPy installed on your machine, you'll need the following code: conda install conda forge TweetPy. Okay. Next up, I have to set my Twitter API keys and my OAuth token API keys. This is how I will create a connection to the Twitter service. So my authentication, TweetPy, OAuth handler, set access. The question from Dahai is, I use pip to install. I don't believe there's a difference. It's just where the code is stored. So either from conda, which is short for Anaconda, or pip, which is the Python distribution. The package should be the same. Just check the versions, I guess. I'm going to create an API object, which will allow me to actually make specific calls as we go along. So to start with, we want to access specific users. So here we have our API object, and if I want myself, it's going to tell me who I am. So who am I, the user? I am Ben the professor, and note the output is in a JSON-like document. So the type may be a TweePy object, but it's really just, it's a JSON wrapper. So here's our JSON, and we can actually fetch it as _JSON. So here's the document. Here's the information about me, the user. Ben the professor. I have no location. I have no profile location. There's a lot of information in here which is going to be absent, mostly because I haven't really maintained very much about myself on Twitter. However, we can also search for specific people. So, by the way, here's more information about me. This is just about fetching the JSON. But now let's get information, and I specifically chose Elon Musk. Elon Musk seems like he's very popular these days, and he's very, very active on Twitter. Excuse me. So if I wanted to fetch a specific user, I take my same API object that I instantiated earlier, and I use the .getUser method to fetch information about Elon Musk. Now, if you want to fetch for any particular user, all you need to go is search for them in Twitter. Let's say somebody type an entity in the chat, and I'll look that entity up. Entity is a user or business or anything. Someone type something in there in the group chat. No one? Anyone? Anyone other than Donald Trump. Let's not do Donald Trump. No, someone else. Anyone else, please. No one else? It's the only one you want to see? How about, let's do the New York State governor, Andrew Cuomo. You really must do a politician. So I'll look up Andrew Cuomo to see if he has an @Andrew Cuomo. He does, @New York governor. Great. So if I wanted to get information about Andrew Cuomo's timeline, all I need to do is put Andrew Cuomo right here. And we'll do that in a moment. So we're getting information about Elon Musk. He has 82 friends. And here's the information about his account. It's got a whole lot of data in here. Now let's do Governor Cuomo. Here's the description as it exists on his page. Father, fisherman, motorcycle enthusiast, 56th governor of New York. And matches exactly what we see here. He's based in New York. He has a website associated with him. Where did it go? Let's see. Here's that URL that he has posted. Is he based in New York? It's hard to say. This is when his account was created. No, that was when his status was last updated. I'm sure it has an account creation date somewhere in here. But you can explore. So at the output of these JSON, you can sort of explore about what's in here. Twitter also has documented what all these fields mean and all these tags mean, and you can actually do your own research. Okay. Next up, trends. So now that we have the ability to access a specific user, we can also look up trends or information about a specific topic or geolocation. Now, Twitter uses this thing called a WOE-ID, sort of an antiquated way of saying where on Earth ID. So every location on the planet supposedly has a unique identifier. I don't think that's really the case, and a lot of them I ended up using don't really work very well. But I created one for the world, which is number 1. I created one for the US, which is this, and New York State, which is this. So if you want to know the WOE-ID, this is a website which will allow you to get it. If I want, like, let's say Syracuse. I'll just do Syracuse. Syracuse, Onondaga County. Here's my WOEID. And what I can do is I can fetch all of the tweets that have been tweeted from this location. So many tweets are tagged by geolocation if you're sharing that information on your Twitter app or on your computer. So all of the tweets that come from a specific place will be tagged with that geolocation. So first I'm going to do api.trendsplace. So give me all of the trending data associated with the United States. Give me all of the tweets that are trending based on New York State. Next, how many? Well, what's the return object from New York State tweets? The list. How many elements does it have? It has one element, so I'm just going to fetch that element. And I'm going to take a look at that data here. So this is what the output of the trends place API looks like. So it looks like it's a list of dictionaries, and each dictionary, no, I'm sorry. It is a dictionary where the first element, trends, is itself a list. So we have Ask 5 SOS, Los Amigos de Janet, 23 Amigos, Guayaquil, iHeart Concert on Fox. These are the things that are honest, that are being tweeted most actively, I believe, over the last 7 days. So 23 Corona. So these are all the popular things that people are tweeting. So the dictionary has trends, as of, created, and location. So let's see, created by would be at the bottom. So this is just the time that I, so it's as of the last 5 minutes is specifically when it's pulling. So it's since, if I pulled it at this timestamp of 22:55, it's as of 22:50. So it's 5 minutes. These are the things that are being tweeted most commonly in the last 5 minutes. Okay. Specifically, it returns you. That is correct. That the trending is, as far as I understand, based on hashtags. Unless Twitter has some other way to go back. It might be also people. So if you do at someone, it might include both the ats and the hashtags. So these are the most common topics. I don't even know what many of these are. National Doctors Day, My Pillow, Soul. And so these are all the things that are most common, specifically with respect to, I believe it's New York State. Yes, New York State. Now, I can do the same for also New York State and US. So what if you wanted to know specifically which of these are specifically New York State trends? Or in other words, which of these trends are popular in New York State, but not in the rest of the United States? And you get the following: Los Amigos de Janet, Guayaquil, iHeart Concert on Fox, Coronavirus Truth, Drake, 90-Day Finance, Monday Vibes. So these are a handful of topics which are popular in the United States. I'm sorry, popular in New York State, but not in the United States. Additionally, if you want those topics which are popular in the United States, but are not popular in New York, here they are. We have BA Light, Colts, -4.5, Honeywell, The Lockdown, Doctor's Day, Nikita, Unfiltered, and Motivational Monday. So New York State is not feeling Motivational Monday today. Now, for those that are not hashtags, I don't exactly know how Twitter deciphers them, but they are considered topics on the trending Twitter data. Okay, I'll take a pause. Any questions about querying for trends using the Twitter API? Or I should say using TweetPy. Any questions?
Are there any other frameworks which interacts with the Twitter API?
Absolutely. There are plenty of other frameworks. You don't have to use TweetPy. And in fact, you can actually just use the APIs directly. Let's check out, search tweets. They give you the curl commands, so the curl commands, where are they? I will do guides. Let's see. API reference. API reference is, I think, what we need. Yeah. So you can actually encode all of these and simply use the Python requests library. We're going to touch on this in the second half of today's lecture. But TweetPy you can think of as an API wrapper. It's an application that actually executes these wrappers in a more, or executes the API calls in a more easy to use, user-friendly way. And we'll also take a look at how to create such a wrapper to make our lives easier. So you'll get to see this, not for Twitter, but for another service that I encoded.
Are there any other libraries that you think may be interesting in interacting with these APIs?
Sure. So I posted them earlier on this lecture. They are near the top, I think. Yeah. So there's, let's see. Twitter apps, Twitter clients. Let's see. I feel like there was another one that I posted. Where did it go? I think it might have been at the top. Yeah, there's a package literally called Twitter, and you can find it on GitHub. So let's try it. Yeah, so there's this thing. So this one is part of pip. It's called Python-Twitter. So you could consider this one as well. But beyond that, I'm most familiar with TweetPy, and I feel like the syntax is pretty useful. Okay. Any other questions? Which brings me to. The question, how do all of these people find those hot topic hashtags so that they can hashtag them in their tweet? I don't know. I don't know how to answer that question. I don't know how people know what's popular. I'm not that person. I'm like the last to know about what's popular. Okay, so next up, we're going to look at the statuses tweet. I'm sorry, the statuses aspect of the timeline. So from here, we can get things like the home timeline, the user timeline, and search. So specifically, if you want all of the tweets from a specific person, you would want to fetch their timeline. So here, if we wanted to get the Rock's timeline, we would say user timeline, The Rock. Notice that The Rock is his handle. He's an actor / wrestler, in case you didn't know who The Rock was. Note, I'm saying count equals 10. This is telling me only give me the last 10 tweets. Okay. Here is a list of the last tweets with a lot of additional metadata. So let's jump ahead to one of the tweets. It gives you the date that it was tweeted, some information, the text of the tweet. ESPN, do I seem like a man who would waste my cheat meals on something that tastes only like bread and whatever the link was? All right, well, it's a dead link, but he tweeted about probably some sort of cheat meal he had. He mentions another person, this Jacob Ruby. He mentions ESPN. He embeds a URL. There's a lot that goes on with respect to each tweet and all of the metadata associated with that tweet. So this is a single JSON package representing a single tweet from The Rock. You want all of the tweets from The Rock, here they are. thank you. Let's actually do line break so it's easier to read. Thank you everyone for this awesome nod for the NBC Titan games. We're all discussing now NBC possibility. As a huge fan and admirer, I'm really pumped up to hear the passing of Joe Diffie online due to COVID-19. Join me now on Instagram. My prep is done for our big Q&A, my friend. Now notice that Q&A, this comes back to our earlier discussion about encoding. So as we're printing this, the ampersand sign is actually getting decoded when in fact it should be a Unicode character. And it has to be, and it has to do with the way that this is being parsed out here. So let's do something along the lines of UTF-8. Probably won't work, but it's worth a try. Nope. Maybe it's encode. Nope. Okay, I lied. There is a way to actually enforce the output print to function, but I'm not in the mood to fight it right now. Notice here there are also some emojis. So these are the things that people tweet. So if you wanted to get all the tweets from a single user, it's just, again, the following: user timeline, the rock, and then the number of tweets from their timeline that you want to fetch. Again, I could do Andrew Cuomo, or I could do someone else. Who's another famous person that we could get their tweets from? Who else is popular? I don't know. Who's popular on Twitter these days? Mark Zuckerberg. Is that Mark Zuckerberg? That doesn't look like Mark Zuckerberg. That's a different Mark. Oh, that's Mark Zuckerberg. You know what? Mark Zuckerberg may not have a Twitter handle. I might go against everything he knows. Yeah, I don't think he has one. Okay, well, we'll leave it at that. All right. That brings us to the API for searching specific keywords. I'm sick. I'm not going to do Corona. Give me another keyword. Let's do somebody give me a keyword in the group chat to search. It's going to return all of the tweets in the last short amount of time. Monday. I like it. Okay. Give me all tweets that are recent regarding hashtag Monday. Okay. Results tweet. It's going to give me 100 tweets. Okay, we have the same output as before. A lot of metadata, kind of tedious to walk through.
Professor, can I ask a question?
Sure.
So in the rock case, in his Twitter, his name is Dwayne Johnson, but another name is @TheRock. So when I query his tweet, which one should I use?
You should use his handle, the @ symbol. You can't.
Oh.
So I believe in Twitter, you can't change your handle once it's been created, but you can change the name that displays. So you always have to use the @ to do the query.
So the handle is which field in the Twitter API?
It's so all right. Let's take a look here. If I open up the .user timeline, it's the good question. I believe it's the user ID. So user ID is the thing that follows @.
Oh, and the Dwayne Johnson is called what?
It's called the screen name.
Oh, got you. Okay. Now it's cleared. Thank you so much.
Sure. Okay. So jumping back here, where were we? Oh, searching for keywords. So Giera gave me Monday. This is just the string. I'm going to now query using the tweetpy.cursor. This allows me to do loops. So if I want to pull n number of objects based on Monday, I can search for 100 objects. I get the results in a big list of tweets. And from there, I can fetch maybe the most recent tweet. So here's one tweet about Monday. Still hoping you will see us. Could really use it right now. PayPal me. This is just a totally random tweet. I don't know who this person is. So you might get something inappropriate. You don't know what you're going to get. Okay. Here are those tweets again. I'm going to give them a line break to separate each tweet. Stop airing Trump Soul. Nuestro tipo de noche. Still hoping you will see us. If there are certain characters that do not display, you can always encode them. And let's try a different hashtag. Maybe let's do, I don't know. What's going on in the world that isn't scary? Hashtag
Music.
music. I like it. Thank you. Okay, I'm going to skip ahead a little bit. And cool. Here are all the tweets about music. Lean machine, hammerhead cases. Just sit back and imagine what trajectory you would have with Metallica. So these are all the tweets about music. So this is just another way to query Twitter. And again, feel free to use Twitter as one of your data sources for your final project. So I'm going to take a quick pause. Any questions about Twitter? The second half of the second lecture, which is 10B, should only take about 15, 20 minutes. So we're ahead of schedule. Okay, no questions, I shall move on. So Wei actually asked an interesting question, which is, are there any other packages to leverage the APIs? Well, Python's request package, the same one that we use to open websites, can actually be leveraged for API calls. And what I've done here is I took a look at a platform back in January called Alpaca, and I wanted to come up with some smart and ultimately stupid investment ideas that I would like to do algorithmically. So I looked at this platform called Alpaca, which is an API for stock trading. I created a user portfolio or platform, and it allows you to do something called paper trading, which is like, I don't know, fake money. It sort of allows you to imagine what would you have done if you were actually trading on the stock market. It trades for, I think it's just stocks. And what I did was I actually converted their basic API request into a set of Python functions that wrap the input parameters around so that it's a little bit easier and more user efficient. So let's take a look at some of the documentation for actually making trades, right? I'll remind you, the stock market, you can either buy or sell stocks of different quantities. Each stock has a price, and you can also have a portfolio or things that are in your account. Think of it like a basket or things that you possess. So there's a whole bunch of documentation about the different actions that you can take as a trader. Where are they? Here. So each one of these are categories of API calls. We have account API calls, order API calls, positions, assets, streaming, watch list, calendar, clock, configurations, and activity. So all of these are different types of API calls that you can make. And let's just take a look at orders for a moment. So this is actually really popular when you're working with platforms that allow for API calls, that you'll get like a really high level platform for actually, calling the service. So here it's telling you, all right, you need to make a GET request. The endpoint is as follows. Take the traditional endpoint and add /v2/orders to the end of it. So that's where you're going to send the request. You have some parameters that you need to send in the request in order for it to be valid. And it tells you what the request is going to do. So what is it going to return to you once you've actually made the request? So here, GET request retrieves a list of orders for the specific account filtered by the query parameters. Then we have a POST request. So typically we look at GET request, fetches data from the internet. A POST request actually takes data that you have locally and puts it onto a server. So here, places a new order for a given account. An order request may be rejected if the account is not authorized for trading, or if you have insufficient balance to make the order. So it does some math and then tells you whether or not it's a valid request. Additionally, you can get an order. So maybe you've made the order and it hasn't completed yet. You can get the status of that order. These are all different specific API calls to an API service. And again, the service is called Alpaca. So what I've done is, after I learned a little bit about the service, I found that there were some patterns I would like to exploit. So I created my own set of definitions for each of those activities I just described to you. So first of all, I imported requests, I imported JSON, and we can actually forget time for a moment. Next, those URLs that it says to actually make the request to, I encode them here. So I can either make a paper URL trade or a live trade. So this is for fake trading versus for live trading. I then can fetch an API key and a secret key. Once I've created an account, I can get them here. So, let's create new keys. I'll fetch my API key, copy, and paste. Same thing for my secret key, copy, paste. So like we did for Twitter, I now have some specific API information that links me, the Python user, to my account in Alpaca. Additionally, based on the different API type, there is a different endpoint. So for queries that are pertaining to my account, the endpoint is account. For information about orders, it has to go to orders, activities to activities, and so on. So each one of these categories in the API documentation, account, orders, position, assets, these all pertain to a different request endpoint or request URL. And then finally, I actually construct that request based on the type of query I have and whether or not it's live. Live means it's going to query the actual account or the fake account, the paper URL. Now, each one of those specific actions I've encoded as a function. So for instance, if I want to get information about my account, I define a function, get account. If I want to get information about activity, I say get activity. Now, what if I wanted to create an order? I do define create order. It takes a couple of parameters. For instance, what is the asset I want to buy or sell? How many do I want to buy or sell? Do I want to buy it or sell it? What type of asset is it? Time in force is they go to, I don't remember what they all are, to be honest with you. And then live, am I querying on this for my actual money account or my fake trading account? So I create all of these different functions to do different things with respect to the Alpaca trading platform. And what I've done is I've created an application not that dissimilar to something like TweePie. And this actually should give you the comfort in knowing that if you're using a tool like TweePie, all it is that someone decided to add some friendly Python on top of the URL calls for that website. I've done the same thing here for Alpaca. So if you find yourself working with a platform that just has information that looks like this, you can convert all of that into a Python program using creating functions, or sometimes you want to create an object. So for instance, let's say I want to create an order. So I want to actually order using my fake account one. Let's change it to 10. I want to buy 10 Twitter shares or stocks in Twitter. I want to specifically ask. It's for a market account, and I don't remember why I chose GTC, but it's a particular. It's required in this case. I don't remember why, but it's in the Alpaca documentation. Oh no, I didn't define these yet. Sorry. Okay, so I create an order, and once I've created the order, Alpaca sends me back a JSON object. JSON object is simply here a dictionary. It gives me a unique ID for the order. It gives me some information about timestamps. It hasn't been filled, i.e., it hasn't been ordered. The symbol, the type of the asset class, the number that I've requested, and that's sort of the simple example of taking an abstract request using the Python request library and actually functionalizing it using just defining functions in Python. Additionally, maybe I want to take this output, which again is a JSON document, and I want to put it in Mongo. Maybe I want to analyze this data later to make maybe more strategic decisions about what to buy and sell. But I don't want to sit here and construct a new database. I don't want to have to worry about what if these fields will change, or what are my keys, what are my primary and foreign keys, how do I relate data. I just want to dump it into a NoSQL database. So I'm going to make a connection to MongoDB. And specifically, once I get my output, I can put it into my paper trade database, either under the collections orders or the collections positions. So I'm going to order more Twitter. Let's do, I don't know, 5 more shares of Twitter. I now have the output of this API call, which again was that JSON document, and I'm going to throw that JSON document into MongoDB. Instead of doing the whole process that we did last time, I created a function to Mongo, which takes in a JSON collection, and you just need to specify. It takes in a list of JSON, and it specifies where you want to put that data. So I want to put it specifically in the database or the collection called orders, indicated here. Okay. Now, what if I wanted to get a whole list of all of the available assets from Alpaca? So Alpaca has another query called get asset taxonomy. You can see that here. Let's see, assets. Get assets. Assets returned from this endpoint will have the same new field. So this is just it's an opportunity to fetch all of the assets available for trading. So I've fetched them. Here's the first one on the list. It's Apple. And now, what if I wanted to just convert all of those just into the symbols? So I want to fetch the symbols from my list of JSON. And I want to just randomly select 10 stocks. So I've randomly selected 10 stocks by randomly selecting 10 indexes from my symbols. So I'm going to just buy these 10 random stocks using my fake trading account. So I do the following. I just create a list comprehension for which I create an order for my symbol, which are the 10 random symbols above. And what's yielded is a list of JSON documents after I've purchased all 10, or I placed orders for all 10 of these random stocks. And then I dump the output to Mongo. Then I can actually fetch those orders back. I make a connection to my Mongo database. And here are all of the orders that I've recently made. I purchased Twitter. I then purchased TRXC, which I actually don't know what that is. Let's take a look. What did I buy? I bought Transenterix Inc., which is headquartered in Mooresville, North Carolina. So I bought this stock on my fake trading account. Or I placed an order for this stock on my fake trading account. I placed an order for BPMP. Again, don't know what BPMP is. We can look it up though, using the fancy Google. BPMP BP Midstream Partners. It's a partner of British Petroleum. And here are all of the orders that I've made. And then if I wanted to delete my database, I can do that. If I wanted to query it, we learned how to do that last time. And that's it. So this is what I wanted to show you in the second half of lecture, is simply that, you know, although websites can be scary, using just the Python requests library, you can actually make any type of request or API call without needing a package like TweetPy. All you need to do is you just need to understand what are the headers, which are sort of like metadata to your API call. You need an endpoint. Where is the request going? And then you just need to make the request. So here it's request.get, the GET request, or a GET request.post, if it's a post request. Any questions about creating your own API calls using the Python request library? Any questions about Alpaca, the trading service? Any questions about APIs, Python? Any questions at all?
In this screen, I see that you are using a reserved keyword type. Is it better to change that name?
It probably is, yes. I used the reserved keyword type out of preservation for the keyword that Alpaca is using. But yes, I probably shouldn't be doing it. Which one was it? This is orders. So if I go to orders, they have a keyword called type here. I kept it the same so that I don't have to rename it in my request. But you're right, I probably shouldn't be using the keyword.
And why do you choose Alpaca for any reasons?
Number one, it's free to use, so I can make unlimited trades free of charge. Number two, it was a better offer. It was a better offer than I tried to use, what was it called? Robinhood, but Robinhood doesn't have APIs that are readily available or serviced by Robinhood. And I liked Alpaca because of their business model is focused around algorithmic trading or API-based trading. That's like their whole business. So I liked the value proposition.
So another question is, how did you build up all the functions? Are you debugging using the request module?
Correct. And honestly, the requests are really easy. And one of the reasons why I like Alpaca is I feel like their documentation is really good. So it's really easy to construct these API calls. But yes, if I get errors, I'm just debugging using the output from the request module.
Thank you.
Okay, any other questions about anything we covered today? Okay, that's all I intend for today's lecture. Oh, sorry, question. Are we still doing mini project 2? Yes. You will have information about mini project 2 on Monday of next week. This week I'm doing my best to grade all the backlog stuff. So you'll have mini project 1 done. You'll have your submissions posted back to you and labs that were due this past weekend. If you have any other questions, let me know. But there is no lab due this weekend, so you're off the hook. So you have a lab due not this weekend, but the following weekend, and mini project 2 is due the weekend after that. So I posted a new version of the syllabus. Let me take a look at that really quickly. So due on 4/12 will be lab 6. Due on 4/14 will be mini project 2. Oh, no, I'm sorry. Due on 4/12 will be lab 6. Due on 4/19 will be the mini project 2. for the last two classes, are we doing presentations? The last class, we will definitely be doing presentations. I'm not quite sure what I want to do for 420 yet. I feel like I don't have any more scripted lectures, but I can certainly put something together if we want to take a poll. So, let's do the following. I'm gonna, in discussions, create a forum, final lecture topic. If there are specific topics in Python related to data, post them here, and I'm happy to do a lecture. I will decide maybe next week. So please post topics you would like covered in the second to last class. Okay, so to answer your question, the last class will be presentations. I've done both classes with presentations, but you don't really need that much time. So I can work with Hernando, who's the other professor in this section, to create a second to last lecture. Next week, by the way, we're going to be covering NLP and regular expressions. Okay, any other questions? Okay, I'm going to hang on the line. If anyone has any questions, feel free to ask. I am available, but you may drop off if you don't have any additional questions. And I'm also going to stop recording. So thank you all for your time today, and we'll catch up soon.